Picture this. You spend hours writing the absolute perfect Python script. It runs flawlessly on your laptop, right? You zip it up, deploy to AWS Lambda, click test, and instantly you get hit with a massive red error. Runtime import module error. Just like that, your deployment is completely broken.
So why does this happen? Well, it's usually because you treated a Lambda deployment like a simple file upload. In this explainer, we're going to look at exactly why your Lambda deployments keep breaking, and more importantly, how to actually package your code for production. You see, to AWS, your code is literally just a text file. Lambda doesn't magically know how to run it. You have to hand AWS a perfectly structured box. And that box? That's your deployment package. This package strictly defines exactly what Lambda is going to execute. If that box is packed wrong, the function crashes.
Now, you have exactly two ways to pack this box. You can use a zip archive or a container image. Let's start with the zip deployment. When you're writing code locally, you're installing libraries, right? Things like requests for Python or Axios for Node.js, but those libraries live hidden away in your local machine's folders. If you just select your index.js file, right-click, hit compress, and deploy that zip straight to Lambda, your code is going to fail. Think about that for a second. Lambda is a completely blank slate. It does not have your local libraries. You absolutely must package all your dependencies inside that zip file, right next to your code. But here's the kicker. Even if you do that, you can still trigger a massive deployment failure. Now, imagine this. You package your dependencies perfectly on your Windows or Mac laptop. You deploy it to Lambda, and it still crashes. Why? Because of a local versus cloud mismatch. You see, your local machine compiled those dependencies for a Mac or Windows operating system. But AWS Lambda, it runs on Amazon Linux. If your code uses libraries with compiled C bindings, think NumPy or Pandas, you are going to have a runtime compatibility failure. You absolutely must compile that deployment package in a Linux environment before ever deploying it to AWS. Okay, next up, we need to understand the upload methods, because AWS will literally block your deployment if you don't know the rules here. If your zip file is under 50 megabytes, you're good to upload it directly through the AWS console or the AWS CLI. But if your zip file is over 50 megabytes, that direct API call is going to reject it. You have to upload the zip to an Amazon S3 bucket first, and then point Lambda to that S3 URL. Oh, and watch out for the absolute ultimate size limit. Your total unzipped deployment package cannot exceed 250 megabytes. If it's 251 megabytes, Lambda permanently blocks the deployment. No way around it. So what do you actually do if your dependencies are massive? You use a Lambda layer. A layer is essentially a separate zip archive that contains all your heavy libraries or custom runtimes. The beauty is, you upload the layer once, and then you can just attach it to multiple functions. Think of it kind of like moving to a new apartment. Your application code is like your suitcase of clothes. It's light, it changes often, and it's super easy to carry. Your dependencies, on the other hand, are the furniture. Heavy and rarely changes. You obviously don't want to carry a sofa every time you travel, right? Layers basically let you leave that heavy furniture right there in the apartment, so you only ever have to upload your lightweight code. But wait, what if your application is, say, 5 gigabytes, and you absolutely need these massive machine learning models? In that case, you abandon the zip file entirely, and you use a container image deployment. Lambda actually allows you to package your code and dependencies as a Docker container image, all the way up to 10 gigabytes in size. You push that image to Amazon Elastic Container Registry, or ECR, and then deploy it to Lambda. But here is the absolutely critical execution detail. You cannot just take an arbitrary web server container and run it. The container must implement the Lambda Runtime API. If it doesn't do that, Lambda has literally no way to pass HTTP events into your container, and the deployment is going to fail. Now, this is where people really mess up. Imagine you deployed the perfect zip file. All the dependencies are there, it was perfectly compiled on Linux, and you still get an error saying handler not found. So what gives? Well, the handler is the exact entry point where AWS Lambda actually begins executing your code. In your Lambda configuration, the handler is defined as a string. Usually it's something like index.handler or app.lambda_handler. The first part of that string is the exact name of your file without the extension. The second part is the name of the actual function inside that file. So for example, if your file is named main.py and your function is called start_process, but your Lambda configuration is looking for index.handler, Lambda is just blindly searching for a file called index that doesn't even exist. It crashes instantly. You absolutely must ensure that the handler string in the AWS console matches your deployment package structure exactly.
Okay, let's lock this down. Here are 3 rapid takeaways for us. Number 1, your deployment package has to contain your code and all dependencies compiled specifically for Amazon Linux, or your function will crash due to missing or incompatible modules. Number 2, zip deployments are strictly limited to 250 megabytes unzipped, and anything over 50 megabytes must be uploaded via Amazon S3. For larger workloads, up to 10 gigabytes, you've got to use container images stored in ECR. And number 3, Lambda layers solve deployment limits by separating those heavy dependencies from your application code, while the handler configuration tells Lambda exactly which file and method to execute.
Before we wrap up this explainer, I have one final warning for you. Changing your deployment package completely overwrites the code. You should always map your API gateway triggers to specific Lambda versions or aliases. Because if you just deploy directly over the latest version, a single broken deployment package will instantly take down your entire production system. So, is your next deployment going to be a perfectly packed box or a ticking time bomb?